All right, so here we go. Conic sections. Okay, we're going to deal with a brief unit. Shouldn't take us more than a couple of weeks on conic sections. There are 4 conic sections. They are parabolas, circles, ellipses, and hyperbolas. And the reason that they're called conic sections is because they all come from a cone. It's how you slice a cone that how you get those. If I take a cone, let me see if I can draw one now. Okay, so if I take a cone and I slice it horizontally, okay, that's going to give me a circle. Okay, because a cone is a circle with an ever-increasing radius, right? So if I cut it horizontally, that gives me a cone. Or that gives me a circle, I should say. If I cut it, oops, come on now, work for me. If I cut it on a diagonal, that's going to give me an ellipse. Okay? If I cut it vertically, that's going to give me a parabola. And if I put 2 cones tip to tip, and I cut it vertically, that's going to give me a hyperbola. Okay? So that's how you slice a cone to get these conic sections. Okay? So, in order to get into this, we need to refresh our memories on 2 key mathematical type concepts. The first one is the distance formula. Okay? So no matter where 2 points are in space, the distance between them is always the difference of the x's squared plus the difference of the y's squared. Okay? And that comes from the most famous theorem of them all, that being the Pythagorean theorem. So if I take this and I make it into a right triangle, I would first need to find this distance down here. And to find that distance, that's kind of like the run in rise over run. So I'd have to subtract my x's. And then I'd have to find this distance. And that's going to be like my rise in rise over run. And that then is going to be my change in y's. And then Pythagorean theorem says that if I square this side and I square that side and I add them together, I get this side squared. But if I want just that side, then I've got to take the square root of that sum. And that's how the distance formula is developed. Okay? So let's put it to work. So to find the distance between those 2 points, I would first start with my distance formula. Now, the nice thing about the distance formula is that it doesn't matter which point, left or right, is the one that I use first. Okay? So if you're a right point first, be a right point first type of person. If you're a left point first type of person, you be you. Okay? Right? What matters is that the x one that I use first had better be paired with the y one that I use first. Okay, or the first y that I use had better come from the same point as the first x. Okay? So this could be -5 minus -3 quantity squared plus 1 minus 2 quantity squared, and I take the square root of all of that. Or I could go with -3 minus -5 plus 2 minus 1. I could go either order there. But the -5, if I use -5 first, I've got to use 1 first in the y's. If I use the -3 as the x first, then I've got to have 2 be the first one there. Okay? -5 plus 3 here is -2. 1 minus 2, I should say, is -1. -2 squared is 4. -1 squared is 1. So I get a distance here of the square root of 5. Okay? In terms of answers, distance is a number, and in terms of answers, we like your numbers to be in simplified radical form. So I would look at the square root of 5 and I would say, there's no perfect square factors in there, so I'm going to leave it be the square root of 5. If my answer had been the square root of 12, I would say, well, that's 4 times 3. Square root of 4 is 2, so my answer then would be 2 square roots of 3. Okay? Not decimal equivalents, okay? Not unsimplified radicals, simplified radical form. Okay? All right? What I would like you to do now is I would like you to find me the distance between those 2 points. I would have walked away. Done. So class is done. I would have been, walked away if I would have made that shot. Unfortunately, I missed. So we've got -5 minus -3 quantity squared plus 0 minus 2 quantity squared. And that is all going to be square rooted. So that's going to be the square root of -2 squared plus -2 squared, which is going to be 4 plus 4, which is going to be the square root of 8. So my distance here is going to be 2 square roots of 2. Because 8 is the square root of 4 and the square root of 2. Okay? Questions on that? Okay? So that's the distance formula. Midpoint formula is the other one. The midpoint is just that. It is the point that's in the middle of 2 other points. Okay? It's the midpoint. So 1, it's a point, so it needs to be in point form. So it needs to be in as an ordered pair. And 2, to find it, we take the average. The middle is the average, and so we average the x's, and we average the y's. So we take the 2 x values, add them together, divide by 2. Take the 2 y values, add them together, divide by 2. Okay. Good? So if I said find the midpoint of the segment joining those 2, I would say, well, that's -2 plus 4 divided by 2. I take my x values, add them together, I would say that that's 3 plus negative 2 divided by 2. I take my y values and I add them together. Okay. So negative 2 plus 4 is positive 2. Positive 2 divided by 2 is positive 1. 3 plus negative 2 is positive 1. There, I almost put negative 1. Positive 1 divided by 2 is 1/2. Whenever possible, we're going to leave it in fractional form. Okay? But sometimes you might get a point that's in decimal form already, and it's got decimal points, and then it might just be easier to put it in decimal form. Okay? But preferred fraction form there. Okay? Questions on midpoint? Yes, ma'am.
So, like, in distance, if the d equals 12 for midpoint, would it be m equals, or how do you want us to label it?
Not m, because m we reserve for slope. Okay? But because it's a point, it's just going to be a point. So we could label it, capital M, yes, or whatever you want it to be labeled as. Okay? So, a circle. Okay? Now, if I had you describe me a circle, you would probably say it's round. And you're right. It is round. Okay? Right? But the true mathematical definition of a circle is the set of all points equidistant from a point. Oops, that's a bad P. Bad P. Now there are two crucial parts to a circle. The first crucial part to a circle is the center. Okay? The center we will call the point H, K. All right? And that is this point over here. So the center is a point. Okay? And it's that point that we're equidistant from. The second crucial part is the radius, and that is this equidistant value. Okay? So if you think about it, we've got a point in space somewhere, right there. Okay? And then the radius is the distance from that point out to the circle. The center is not actually on the circle. It's off of the circle, it's inside the circle, but it's not actually on the circle. So the center, if you plug the center point into the equation, you would get a false statement. You'd get 0 equals something. Okay? Alright? The equation of all circles is this. X minus h, quantity squared, plus y minus k, quantity squared, equals r squared. And this center point, this brings me h, and it brings me k. The radius gives me r. Now, a couple of things about that equation. First off, because we are in H and K are in parentheses, we need to, in math, think opposites. Oops, I forgot the second P in opposite. Having troubles with P's today. Okay? So you need to think opposite. If it says x minus h, that really gives you a positive h value for your point. Y minus k really gives you a positive k value for your point. Okay? And r is squared. And those are the two things that we have to think. We have to think oppositely for our center, and we got to look in the equation, r is squared. Okay? So, here is an equation of a circle. X plus 3 quantity squared plus y minus 1 quantity squared equals 4. From that, I can say that this is the h part of my center. Correct? Because it's attached to x. Thinking oppositely, because it's inside a set of parentheses, that's going to give me the center at -3, comma something. Is everybody clear on that? Okay. Lukey, where you're shaking your head. What's up, my man? The center of the circle is going to be these two numbers right there. Red and green. Okay? But because they're inside a parentheses, I got to think oppositely. Okay? So plus 3 is in the parentheses, so I should be thinking positive 3. But opposite, I'm thinking negative 3. I should be thinking negative 1 here in green, right? But thinking oppositely, it's really positive 1. Okay? I'm thinking oppositely because it's inside parentheses. Okay? So that point, 1, 2, 3, comma 1 is right there. Okay? Now, this number here is r squared. So I've got to square root that number to get it. Right? R squared is 4, so r is 2. So in every direction from my center, my circle is 2 units away. Okay? So for me to graph, that means I've got to go right 2, up 2, left 2, and down 2. And then from that, I got to make what looks somewhat close to a circle. Okay? This is not a circle. Okay? So don't do that. Okay? So let's somewhat make ourselves a circle. You might have to, like, I usually go around 2 or 3 times. Because every time that I go around, it gets more and more like a circle. Okay? And then if you have this cool thing on your paper that allows you to check to make sure that you made yourself a circle, look at that. That's probably the best circle I've drawn all day. Don't act like you're not impressed. What?
You've only drawn 2 circles today, so...
No. I had a class before. I drew 4 in that class. Yeah, that's my 5th circle today. Maybe I woke up this morning and I drew some circles. Don't you? You just get up in the morning and, I want to draw circles today.
Actually, just go sit and draw.
Okay?
Since I prepped in my morning, instead of having coffee, I just get psyched up
Psyched out about math. It's a great stress reliever. Okay? All right. So, the difference with this one is that I now have coefficients in front of my squared terms. And that's a key. Okay? Circles don't have coefficients in front of their squared terms. Okay? So I need to first get rid of them. So I'm going to divide every term by 7. Okay? So then that gives me x squared plus y squared equals, I want to say 16. Yeah? I think it's 16. Back me up on that. Someone? Yeah? Yeah? 16? Okay? Which really is x minus 0 squared plus y minus 0 squared equals, I'm going to write it as 4 squared. Only because it's the best game ever. Well, don't be shaking your head that 4 squared is not the greatest game ever. Yeah, exactly. Exactly. You guys think I'm up here and I'm just spewing out these facts left and right? Well, you know what? Sometimes I'm right. 4 squared is an awesome game. Okay? Because you get to talk a lot of smack in it. Okay?
If you screw up, then you're just looking like an idiot.
It doesn't matter. Then you go right back. You go back to square one, and then the problem is when you play 4 square with an 11-year-old, they suddenly start making up rules mid-game. Okay? And then it becomes, what? You know, yeah. But I'm not above smack talking my own kids. Okay? Yeah. So where's the center? Center's at the origin here, yep. Okay, what's my radius? 4 is my radius. Okay, so I go to the origin. There's my center. If you wanted to, you could, instead of putting a dot there, you could just put a C there for your center. Okay, you know, that's crazy talk. Hey! Okay, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So then there's my circle, and then, oh, this one's bad. I'm going to have to go around twice on this one for sure. I know, because it's bigger. See, with bigger comes more issues. Or you can just, kind of like make it nice and big and thick.
But no one will ever see your mistakes.
And then nobody sees your mistakes. And if they do, you get the small eraser. And you just, yeah,
That is artist quality.
That's good stuff right there. I don't care who you are. Okay? Oh, I gotta get going. I only got 3 minutes. So, if we're writing the equation of a circle, we need the center and we need the radius. So if we're writing here, I'm going to start with my equation, x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. And then this is h, this is k, and this bad boy over here is r. So then I just write that in and I say, well, that's x minus h is 3, quantity squared, plus y minus k is negative 2. So minus negative 2 is like plus 2. And the square root of 5 squared is 5. So there is the equation of my circle. Okay? Now, so that one goes pretty quick. This one, so my center is at h, comma, k, but it goes through that point. So what I first need to do is I first need to find my radius. How am I going to find the radius? If I know where the center of my circle is, and I know that a point that the circle goes through. Distance formula. So I'm going to need to find the distance between those two. So that's going to be 2 minus 5, quantity squared, plus -4 minus -12, quantity squared, and take the square root of that. So that's going to be -3. That's going to be +8. That's going to be 9 plus 64. 9 plus 64 is 73. And I'm going to leave it as the square root of 73. I really don't care that it's like 8.6 something. Okay? If I were graphing it, yes, then I need to know that it's 8.6, and I'd have to go in every direction 8.6. But for in terms of this, it's just going to be x minus 2, quantity squared, plus y minus -4, quantity squared, equals the square root of 73 squared. And that's my equation of the circle. Okay? On your way out, I have a worksheet for you that deals with all things circles, distance, and midpoints.